All right. It's PreCal12. This is part 2 of our review, units 3 and 4. That's Maddie. Yeah, she's introducing us today. That's right. We're really excited about math. Hope you're excited about math too. Let's get it underway. Part 2 of our review process.
Follow me on Twitter. T-Lord97.
There we go. Right there, Thomas. A little shout out there. All right. Now, let's begin on unit 3. We'll go over number 1. Make sure that we're all clear on that. And if you have questions, those that are in the audience can help us out. And we'll go over those together. Make sure you remember the podcasts are going to be posted at the top of the introduction page, along with the answer sheets on the top of the intro page as well. All right, let's do this thing. Now, number 1 on unit 3 says this: 3 to the 5x plus 1 power equals 5. Now, what I'd like to do is this. I know this is kind of unrelated, but I want to do 2 of them because I think that you'll understand it better if I do. Look at number 10. Number 10, too, I'm going to put on this side, 16 equals 2 to the 7x minus 5. Now, both of these look the same. The only difference is that this one has a no calculator symbol on the top. So because of that, we approach it different ways, although we could do it the same way. We're going to approach it in 2 different ways. On the top here, notice that the bases are not alike, so we can't cancel out. So to do this, what we have to do is we're going to take the log, or let's say the ln of both of these sides. So if I took the natural log of both sides, what I could do now is use the power rule. Okay, now right when I say that, something that I'm going to put on the test is all the rules, so the log rules. I'll put that on the test, okay? So when I end up setting this up, what happens to that power rule with the 5x plus 1? Nice, Keegan, good. So the 5x plus 1 will be multiplied by ln of 3 and will be set equal to ln of 5. Remember, these are being multiplied here. Now, how could I get x by itself now? Divide by? Good, yeah, let's divide by ln of 3 to where when we then cancel, we'll have 5x plus 1 equals the ln of 5 divided by the ln of 3. Now again, we're almost done. We're still not quite there. We know that if we have the ln of 5 over the ln of 3, and it's set equal to 5x plus 1, what could I do to solve for x now? Bingo, good. Nice, Lucas. So if I subtract 1, divide by 5, x will equal the ln of 5 over ln of 3 minus 1, then divided by 5. So if you get it on your calculator there, let's do it. Let's go ln of 5, divide that by ln of 3. Once I get that, I'll subtract by 1, divide by 5, and I'll get 0.093. So x equals approximately 0.093. And that would be what my x answer would be for the value up top. Okay?
Is that going to be multiple choice?
Great question. Some of them, last year, I noticed as I've done this over the last couple years, that there's some that will be beneficial for you to have multiple choice on. Some of them it will not be. I know that last year, the frustrating part is I knew that people knew it, but they psyched themselves out because they saw different answers. I think it's better that if you got to this part right here, but maybe you made a mistake to get to here, that on some of the problems that I could give you back some credit for. So that I'm going to make it kind of a little bit of both, give and take a little bit. Not sure, probably like 30 problems or so. That's probably what I'm thinking. So, all right, now the next one, number 10, is a no calculator one. So you could do the ln of both sides again, except this time I want to do it a little bit different. This time I want to do it to where we have the same base. So if we can get 16 to have a base of 2, we can actually cancel those out and be able to solve for x in that way. So 16 would be 2 to what power? Yeah, good. Is that Luke right there? Nice, Luke. So 2 to the 4th power is 16. Do we have the same base now?
Yep.
We do. We could cancel out those 2's to get 4 equals 7x minus 5. Now if I add 5, then divide by 7, x is then equal to 9 over 7, and that would be my answer for number 10. Okay? Correct. So I did both, right? I did both. I did 1 and 10. On number 10, what I'll do is I'll put get the same base. Yep. Right on. All right, let's go over number 2 here. And again, I'll put that formula on that.
No.
Put the formula on for number 2. Number 2 refers to an account that is compounded continuously. Well, the one where we compound continuously, I'll give to you. And the formula would be the PERT formula. A equals PE to the RT. Okay?
Is number 2?
Number 2. Yep. Dulce. I think it's 12. 2. Yeah, it's 2. An initial deposit of $3,000 is made in a savings account. Now, $3,000, if that's initial, what do we know about that?
That's going to be the principal.
Yeah, that's our principal. So we're going to put that in for P. It then goes on to say the balance will double in 7 years.
So then you put 6,000 for A. That's your. I forgot what A stands for. But
The amount you get out, right? A is the amount you get out. All right. Now, what do I put in for everything else
so
there?
You don't know your rate, but you know your time because it's 7 years. So you're going to put 7. There's going to be 6,000 equals 3,000 E to the R times 7.
Perfect. That's exactly what I got. Now, at this point, if I divide by 3,000 on both sides, just like Tyler had said, to get that base E by itself, I should get 2 equals base E to the 7R or R7 either way. Now, how could I get that R by itself?
ln.
Exactly. Well, I do the ln of both sides, like Tyler said. What does that do on my right side?
Cancels.
Yeah, a little cancel party. Good, Thomas. So we have the ln of 2 equals 7R. Divide by 7. Divide by 7. ln of 2 divided by 7. Divide that by 7 now. That gets me 0.099
So that'd be 0.1.
is my rate.
9.9%.
Good. I put 9.90% or what have you. 9.9% is fine. Okay. Tyler, were you saying something?
No, I wasn't saying that.
Awesome. Good to go. I know this is riveting. But this is going to be, I think, the most beneficial for you when you go and review. Okay. All the podcasts should be up tonight over all 3 of the sections there. Yeah, Lucas.
How many questions, please?
I'm thinking 30.
Wait, the exam?
The exam 30.
That's doable.
Yeah, it's doable. You got it.
Have a little party after.
Little party, little
Plug it in. chug it party.
POC, plug it and chugging,
We should have a cake fight.
all of the above.
Darty, each day party.
Coach Jay, did you get
A darty? Is that the
did you
new
see
word?
that picture
What
I
Insta it?
tagged you in? It was me, Nick, and Jesse. Getting
Yes.
some ice cream.
That was
We're
awesome.
online right now.
Because I commented, didn't I? I commented on it?
You just
Hey,
favored
Rob,
it.
we're
No,
live.
I think I did. I thought I commented on it.
What'd you say?
I said
We're
something
live
back
right
on it.
now.
Said,
Oh,
We are live.
we're live.
really, oh, we are live. I apologize. I'm sorry. As we continue, I'm sorry. I've forgotten that we were live. We're live. My YouTube followers right now are on the edge of their seats, so we got to continue. The show must go on. Numero 3. Number 3. All right, here we go. Let's go number 3. All right, now this one is one where some more of the log formulas are going to come in handy. So we want to make sure that we set it up accordingly. All right, so what about the left side? What do we need to do in order to cancel out the logs on both sides of the equal sign? What do we need to do on specifically the left side?
The left side, change it to multiplication. Why don't you just cancel out all the log base 8s?
We can't yet because we've got to make sure that it's 1 first.
What do you mean 1 first?
So like Keegan said, because this is an addition, right? I'm going to give you all those log formulas, so you're going to be good. But since it's addition, what you'll have is log base 8 of 7 minus x times 3x plus 5.
Have Sal tell us what this.
Okay? Yep. So now on the right side, we have log base 8 of 24x. Again, if it's addition, we multiply. Subtraction, we're going to end up dividing.
But now you can cancel. Right?
Correct. Now we can cancel, little cancel party. Because now we've got everything's combined in 1. So both log base 8s cancel. Now we could just solve. So 7 minus x times 3x plus 5. Now we could just kind of figure that out there. So 7 times 3x is 21x. 7 times 5 is 35. Negative x times 3x is negative 3x squared. And negative x times 5 is negative 5x. Equals 24x. Now we'll get everything on one side. And since this negative 3x squared is on the left, let's get everything to the right side so the x squared is positive. So if I move everything over, what I have is 0 equals 3x squared, because I'll move that over, minus 21x, minus 35, plus 5x, plus 24x. Now, is anyone stuck right now? Or does this make sense? So we're just moving everything to where the x squared is positive. Now, at this point, we'll combine x's. So negative 21x plus 5x is negative 16x. And then plus 24x here. So that should actually be 8x. So 3x squared plus 8x minus 35 equals 0. Now, what's a good way to solve for this now?
So you can
No,
fact.
you can take out 3.
Or you do A times C.
You could do A times C and kind of attempt to do that. Yeah, you could do quadratic equation as well. Personally, I would go quadratic route. That's just me. But I would solve it in that way. I'll tell you right now, if you could get to where you could get to this point, that's really the big key. And then factoring should be the easier of the parts there. So if I were to continue here, I would then factor or use the quadratic equation to solve for x in this case. My big point, I know you know how to do that. My big point is getting you from here to here, okay? Does that make sense? Is there anyone that needs me to continue? Or does that make sense there? Solve for that? All right. Very good. Very good. All right, let's. Yeah, what's up, Tyler?
You can factor that.
You can?
You can factor that.
What would it be?
It would be 15 and 7. Yeah, 15 and 7.
So here's what you have here, right?
Right, I think this is positive 8. Yeah, yeah. Yeah, good.
That's what I did. Just make sure you keep it down, y'all, because I want to make sure we're in a podcast so it doesn't get picked up. Okay. We won't go on tangents like I did earlier. All right. That's my fault. Does that make sense, so Tyler?
Yeah, that's crazy. Awesome.
All right. So I've got x plus 5 and 3x minus 7 when I factor. So just so you have the answers there, x equals negative 5 and 7/3. So those two right there would be your answers in that example. All right. Right now we're on number 4, I'm sorry. All right, number 4. All right, on this one we have e to the 2 ln of x plus 1. Anyone have a strategy of what we could use here? I can't cancel out yet because that 2's got to be out of there. So I've got to get that 2 to where it isolates just the ln. So what could I do with that 2?
Number is this? 4?
Number 4. Yeah, we could shoot that 2 as a power to where it's e to the ln of x plus 1 to the second power. All right. What do I do with e and ln now?
They cancel out.
Yep, there we go. So what do we have left?
X plus 1 squared.
X plus 1 squared would be
So
the
you
answer.
factor.
That right there, you could just keep it as is. Sure can. That's all we're looking for on that one.
Psych exam.
Perfect. Good luck, y'all. Tear it up.
Psych exam.
Have fun. Don't fail.
Nice.
All right. So if I was to graph ln of x on number 5 here, what would ln of x look like in terms of a graph?
It's a great question. Go in your hand calculator. ln of x.
Wouldn't it look like this traditionally? Number 5?
How do you change it back from that previous lesson that we were on?
You could go to mode on the top top left next to second. Just make sure that it's in function mode, not in sequence. All right, got me there?
Nope.
So go to mode, you see next to the second?
Yep.
Teachers and students.
You wanna make sure it's
part of the
function
interaction.
instead of
I have
the
one
sequence.
announcement to make. All students that are taking
They left
the
early.
AP exam today at noon should now be dismissed to go and get your lunch. Thank you.
All right, so think about it in terms of this. If our asymptote is at 0, right, in ln of x, the only way that this vertical asymptote is going to end up switching is if what happens? What type of transformation, vertical or horizontal? Horizontal, right? Because it's a vertical asymptote, so left and right is what we're concerned with. Very good, Keegan. So if I looked at that, the only thing I'm concerned with is where is it at 3x minus 9? So how does 3x minus 9 impact this vertical asymptote? So what I could do is just set 3x minus 9 equal to 0. If I just set that equal to 0, what it does for me is if I add 9 and add 9, divide by 3, x will be equal to 3. That will be in terms of my vertical asymptote. So what it's going to do is at 0, it's going to transform, because it's on the inside, it's going to go to the right 3. That make sense?
So 3 is your vertical.
Correct. X equals 3. So you would have x equals 3 as my vertical asymptote. Now, what about my x-intercept? What would be my x-intercept here?
How would you find that?
Well, remember, and I put on a previous podcast,
You set all the y equals, or all the y's equals 0.
good, both of you, nice. Lucas and Tyler said in 2 different ways, but the same thing. Plug 0 in for y and we'll be okay. So what we'll have is 0 equals 2 minus ln of 3x minus 9. So let's just go step by step. We could subtract by 2. We don't like a negative ln, so we just make this positive and the other one positive. How do I get rid of that ln here?
E.
Yeah, base e, so e to the second. So right now we have e to the second equals 3x minus 9. So if we go backwards here, we'll go e to the second and equals 3x minus 9. So what we'll do is we'll add 9 to that value, divide by 3. I got 5.46 equals x. That right there would be my x-intercept. So we put it in terms of 5.46 comma 0. And that would be what would be on number 5.
How did you change the negative to a positive?
Because when I subtracted 2, it'd be negative 2 here. So if I change the sign on this way, I can, as long as I do it to the other side. That's it. Did you see that there?
They both become, by dividing it by like -1. Whatever.
Correct. Really, yeah, technically you're divided by -1. So how do I get rid of that ln on the right side? I do base e on the right, which does it also to the left-hand side. And that's how I get e to the second equals 3x minus 9.
And then do you need to continue going from there?
Correct. And then to add 9, divide by 3, I got 5.46.
My calculator's not working.
Not working for you?
No.
Would you do e to the second, get an answer?
Yeah, I did my graphing. It says when I graph graph, it says invalid dimensions or something.
Yeah, you don't have to graph it there
I know, but I'm just saying
for in the future. If you go to Window, or if you go to Zoom, which is right next to Window, in the middle, on the top there, you see it there? Put Zoom, and go to Zoom Standard, which is
it
6.
says invalid still.
Okay, I'll have to just check it out. It's no problem. I'll check it out here shortly. All right. Let's look at number 6. Number 6 is another good one. I appreciate y'all's patience today. I know this is not the most riveting thing, but I know that it'll be most beneficial thing for us. Yeah, what's up? Go ahead, man. Now, number 6 is where we have ln of the square root of x cubed all over y. Now, if you have the square root of something, what that is it's the same as taking it to the 1/2 power. So this whole thing would then be taken to the 1/2. Now, in separating this from each other, what I can do is I can bring that 1/2 to the front based on the power rule. So I should have 1/2 ln of x cubed over y. My next question is this, though. How could I break up that x cubed over y for number 6?
Well, you have the change of base, not the change of base, but isn't it where you can have two different things? So it'd be 1/2 ln x squared and then minus
X cubed, yeah, minus.
x cubed minus ln, or 1/2 ln of y.
Perfect. Only one other thing is if I shoot this 3 to the front, then I'd be left with 3/2 ln of x minus 1/2 ln of y. And that right there is what we call expanding. That's how we expand a natural log there, or a logarithmic equation, either way. All right. Also, number 7 is one where you just take it the opposite way. And so just be sure that you do the power rule first, especially the first and second. Then we combine those together, be able to solve for what that, when we condense it, what that would look like. All right, questions on that?
So, yeah. Okay.
Tyler, you good?
Yep.
Right on. All right, look at number 8. Look at the 4 there. We're just going to touch base on those real quick, making sure if there's any questions, we could kind of go over that. See if it's either true or false concerning whether they are equal to each other, okay?
Number 8.
Yep, these are just 2 of them right here. All right, look at the first one. What's the base of a log if there is no base?
10.
Yeah, 10. So in order to cancel these, what would this one have to be? 10, right? Okay. And I'll tell you what, I'll put some of these log rules on there. I'll put those log rules on. That's no problem. Yeah, so since it's got to be 10, it should not cancel out. Well, actually, now that I think about it, let's try this. Let's try it. Change it to exponential form. Okay, instead of me trying to jump to conclusions, shoot the 10 to the other side. And I'll even put the exponential form in.
True.
All right. So when I shoot it over to the other side,
B1.
Lucas, you said, yeah, it said 1 equals now 10 to the 0 power. 10 to the 0 power is 1. 1 equals 1. So anytime there's a 1 on the outside, it does equal 0. That's actually true. That will be true there. What about the next one? E to the ln of x.
Cancel out, so it's true.
Yep, that's going to be true. All right, what about the next one?
No idea.
Well, the base down here is 10, right? These would not be able to cancel out. There's nothing that could cancel out here. So guess what? And it's false. There's nothing there within our forms, within our rules that could cancel out. What about the last one, the 4th one?
True.
Yeah, it's true because if both bases are alike, they cancel out to equal 1. That actually will be true in that case. All right? Now, number 11 and then number 12 I just want to talk you through that. I did do one earlier with my vertical. How did I do that with this class? Yeah, vertical asymptotes and holes and that sort of thing. Numbers 11 and 12, that's very similar to what we've done in the past. So I did one of those kind of already on the podcast on the first one. So you can look back at those and kind of look at them there and go for it. One thing just to be sure of is number 14. If I had one, number 14, that was just e to the x. So let's say y equals e to the x, or say it was f of x equals e to the x. The basic exponential would look something like this. So if I say, hey, graph this, and let's say this is at 0, 1, what I could do is I don't think you can use your calculator on these. What you could do, if that's your basic e to the x, and I had now e to the x minus 1 plus 2, what type of transformation would take place from this equation? Yeah, we know it's going to go up 2. And what about the x minus 1? Right 1, yeah. So this right here would go right 1 and up 2. So now what was at 0, the horizontal asymptotes now at 0 will actually be at 2 now. And it will be just the same equation. Now all of a sudden it will just be going upward, up 2. So my vertical or my horizontal asymptote for my base E would be at y equals 2.
Your horizontal asymptote is at x, or y equals 2.
At y equals 2, exactly. All right, I'm going to hold off on that for Unit 3. We actually did not get to Unit 4. That's okay. I'll try to get to as much as possible there. Hopefully that was helpful for you. At least you can knock out 1 unit. Again, I've already done the other 2 units with the other class, and so each time I'm going to do a different one. And then this next class, I've got 1 more. I'll try to do most of Unit 4, if not all of it. And then Unit 5 we'll kind of put off until later on that. Okay?
How many units are there? 6?
5, I think. Only 5. Yeah, only 5. We'll go through that and be good to go. All right, this is Coach Jay on this podcast. Hope everything was good. That was part 2. We'll look at part 3 a little bit later. Have a great day. Bye.